All right, so explore with Desmos. There's a lot of things you could do in here. So if you're nerdy and bored, or a high school math teacher and bored, this is where you go. But for our purposes, we're going to hit Start Graphing. And then in here, we can write f of x equals, and we can type it all out, right? Or just hit it all here. So we went 2x to the fourth, and we could just do it all that way. I'm not going to waste any more time. I already have it in here. So we want to take a look at this graph. We want to make sure that that toggle is turned on. And here it gives me the graph. And it really just looks like, it doesn't look like much. We'd have to see a different version, a different view to kind of get a better look at it. But here I could just click on my zeros and it'll tell me. So here I have 0.5 and the other one is -3. So that tells me I am looking at my possible zeros of -3 and a positive 1/2. Okay, so we have our possible zeros. And these, again, are my real zeros. The same thing as an x-intercept, right? So now I want to confirm that with synthetic division. When I'm dealing with fractions or anything like that, I'm going to try those second. So the first one I'm going to do is the -3. And using synthetic division is going to look different on my computer just a little bit. But my coefficients are 2. We have a 5, 29, 80, and a -48. Let's get some space in between those here. All right. So I'll draw my dang line here. There we go. That's good enough. And all right, so the first one always drops down, right? So the 2 goes straight down and we get a 2. And then we multiply -3 times 2, and that gives us a -6. Oh, I don't want it there, do I? That gives us how about a -6 there? All right, and then we add down. So 5 plus -6 is -1. Multiply -3 times -1, and we get a positive 3. Add down 29 plus 3. We get 32. 3 times a -32 is a negative C. It'll be negative 96. All right. Cool. And then 80 minus 96 is a -16. And a -3 times a -16 is a positive 48. And that is my remainder of 0. Excellent. All right, so now I want to synthetically divide out the other 0 as well, which was a positive 1/2. So I'm going to take that positive 1/2, and I'm just going to synthetically divide it out of what was left over. So here we had 2x to the fourth. Right, so here I had 2x to the fourth. So this is x to the fourth. I divide out 1x. So now this is 2x to the third minus x squared plus 32x minus 16. And again, we're finding 0, so that would be set equal to 0. But we're going to divide out the other x-intercept, or my other real 0. And we're going to do that synthetically. Let's see if I can create my little board again. And we're hoping then that underneath my 16 here, this will end up being a 0. All right, so the 2 goes down, and I end up with 2. And then 1/2 times 2 is nice. That's a positive 1. And a negative 1 plus 1, that's good. We get 0. And anything times 0 is going to give us 0. And 32 plus 0 is 32. And 1/2 times 0, or excuse me, 1/2 times 32 is a positive 16. Excellent. So that gives me that 0 in that remainder spot. All right, so what I have left over now, since I have a 0 in my remainder spot, remember that was the y value when that was my x value, right? So we already saw that negative 3 comma 0 was a point on that graph, along with 1/2 comma 0. Right, so my y value is my remainder. So that's using the remainder theorem to confirm that these are actually zeros. So I now know that, excuse me, I know that x equals negative 3 is a 0. And I can also say from this synthetic division that x equals, excuse me, positive 1/2 is another 0. So I have 2 of those zeros. All right, so what am I left with? So x to the 4th, this is x to the 3rd. So this is left with something x squared. So now I need to solve the problem, the remaining equation, which, let me get my equation in there, which is 2, here, this 2, and that's going to be 2x squared plus 0x's plus 32 equals 0. That's what I have left to solve for. So I need to solve this 2x squared plus 32 equals 0 to get my remaining 2 zeros, right? I knew there were going to be 4 zeros, and here I got my other 1, 2, and here I got to find my other 2. So we would solve that by subtracting 32 on both sides, and we'd end up with, oh, no, excuse me. I wanted to copy, paste, and let's say equals negative 32. All right, and then I would divide by 2, so then I'm left with a negative, excuse me, equals negative 16 over here, and on the left side I would have simply x squared equals negative 16, and then when I solve that, I take the square roots of both sides. All right, and I'm left with, I don't need that anymore, x equals plus or minus 4i. Okay, so that gives me all 4, right? I needed 4 total zeros. So then I could say that my zeros are, I have these 2, negative 3, and a positive 1/2. Okay, so my final answer would say zeros are. I don't even have to put zeros are. I could say 0 semicolon and then plus or minus 4i. That tells me 1, 2 zeros here. Negative 3 would be a 0, and 1/2 would be my 4th 0. All right. So now, if I wanted to, I could write that in linear factored form, right? So this is what it says. The linear factored form of a polynomial is anything in the form of f of x equals, and then here we have x minus a in parentheses times x minus b in parentheses times x minus c, where a, b, and c are zeros. Well, here are my zeros. right? So in theory, I could write that in factored form. Um, this is going to help us here in a moment when we solve another type of problem going from zeros back to the original. So if the idea of starting with a polynomial in standard form, going all the way to identifying my zeros, if that would be considered forwards, right, what we're about to do is we're going to write a fourth degree polynomial function with real coefficients that has the zeros 2, -1, and 1 plus I, right? Notice I'm kind of skipping over this idea of the challenge problem. I want you guys to try and do that on your own. So you can pause and write this problem down. I don't know what I'll give for actually solving it correctly, but I think it'd be pretty good. So use that as a challenge. Try and do that problem if you can. All right, so let's tackle this problem here. Write a fourth degree polynomial function with real coefficients that has the zeros 2, -1, and 1 plus I. All right, so in order to write this function, what we need to do first is get it into this form here, into factored form. And then once we're in factored form, we can then multiply it all out, and we'll multiply everything out, and we'll end up into standard form. All right, so we want to write it in standard form. So one way of doing that is we really need to pay attention to getting this into factored form first. And we need to do that in a way such that we don't screw up, because here we have a 0, but really what that is the factor is x minus 2, right? So if the 0 is a positive 2, the factor is going to be x minus 2. So we could write this here. I got to do this appropriately. We could write the factored form here as f of x equals, and the first factor we know is x minus 2. The second factor we know is x plus 1. The third, well, I have to say minus, so this is going to say x minus 1 minus I. Now, how in the world did we get to that? Well, if you go back and take a look here, x equals, let's say x equals -3. When I found the 0, I get x equals -3. I could set it back equal to 0, and I'd end up with, if I add 3 to both sides, I'd end up with x plus 3 equals 0, right? So really the best way to go about doing that is, when I'm starting with these 3 here, I would say x equals 2. The next one would say x equals -1. The next one would say x equals 1 plus I. Well, when I do that, right, I subtract 2 from both sides, I get x minus 2. I add 1 to both sides, I get x plus 1. Well, I'd subtract the 1, and then I'd have to subtract I, so I get x minus 1 minus I. Well, I need a fourth degree polynomial. Well, currently I only have 3 zeros in here. So in order for me to have real coefficients, right, I need to have real coefficients, I need the conjugate of this guy as well. So I also end up with x equals 1 minus I. And over here, that factor would turn out to be x minus 1 plus I. Well, it would be x minus 1 plus I. All right. So now we're in factored form. And from here, you'd have to multiply. My suggestion is to multiply these two first. So you'll have a trinomial times these things over here. And then I would multiply these two. Now again, you're going to distribute x here, here, and here. The -1 to all 3 and the -I to all 3. Simplify, simplify, simplify.